Hello, I'm Ryan Harris, Sales and Market Manager for High Speed Interconnects, and welcome to episode of our corporate podcast, Network Connections, the podcast about information communications technology, presented by us, the Siemon Company. Today we have our high speed team. We have our product manager, John Corsi.
Hey.
We also have our signal integrity engineer, David.
Hey guys.
And also our mechanical engineer, Rob.
Hello.
So the four of us, we typically work together with customers, and what we do is we work through the challenges that exist when trying to connect network equipment within a data center.
Exactly. David, real quick, could you tell us what SI stands for?
Sure. SI stands for signal integrity. It's essentially, quantifying the level of signal to noise ratio throughout a channel. So I make sure that all the solutions we provide get our customers' data from one point to another point. And I, often work with network engineers to solve connectivity issues and interoperability issues.
So sometimes, what kind of questions do you get? Do people wonder, like, when to use copper and when to use fiber, or is it about gauges? What kinds of things do you get into?
So, as a team, there's all tons of different reasons for picking different things, but one of the things that people come to me mostly is, how to reduce latency. And I know one of the things is very often in 25 and 100G systems, they're using forward error correction, FEC, as it's called, and this often adds latency. And if you use high performance cables that have higher performance levels than standard cables, you can override this function and save some latency in your system.
So do a lot of customers use FEC, or would you say that FEC on is more popular than FEC off?
Well, it all depends on the customer's application and what their needs are, which really drives whether they're going to be using FEC or they're not going to be using FEC.
So Rob, could you tell us a little bit about what you do with the mechanical side of the cables and some of the challenges that you overcome?
Sure thing. What I basically do as the mechanical engineer for the high speeds is I make sure that all of the cables fit into the connectors properly, all of the connectors fit into the cages properly.
What kind of standards dictate that interoperability?
So there is actually a group of people called the SFF that put out standards specifically for SFP, QSFP, and with those standards, you make sure that every SFP connector will work with every SFP cage. Same thing for QSFP.
That would explain. We have these different products from different companies, and they all need to work together.
Exactly.
How long would you say typical testing lasts, in time? Do you test cables for years? Do you test them for hours? Do you test them for weeks? How long does a typical test last on a cable for qualification?
For qualification of a certain cable would probably take.
It's got to be like 500 hours and at least 500 hours of heat aging.
Yeah, because there's heat age testing, there's flex testing, there's obviously signal integrity testing, retention testing, insertion force testing, vibration testing.
Hey, Ryan. Typically, when a customer qualifies our products, how much time do they put into it?
It's really depending on the customer. Some customers are just looking to plug in the cable and make sure they get a network connection, and maybe they will run some tests for a few hours afterwards and then say that the cable works. Others take a longer approach where they'll have it in an engineering lab and just let it run in some equipment for a longer period of time. And others have value add resellers that do the testing for them, and so it's really dependent on the customer. But
And David, how about, I hear the term all the time, running traffic through a cable. What does that refer to?
So that would usually be when you have a switch or a server, and on the other side of the switch or server, you have either a switch or a server, and then you're sending information from one device to another device, and the information has to be converted to an electrical signal and then sent through the cable to get to its destination.
I notice sometimes that cables have multiple gauges for the same length. Could you tell me why?
Yeah, that goes back to what I was saying earlier about the forward error correction and a higher performing cable. So the gauge is directly related with how lossy the cable is, how much insertion loss, and how much the signals gets to the other side of the cable. So at 25G or 100G networks, if you want to remove that latency, you can go to a higher gauge cable, which will have better performance, and you'll have less errors in the end of the day.
And why can fiber transmit over such a longer distance than copper?
Well, copper is pretty lossy as a medium, so you have much higher losses. So going to longer lengths is more difficult. Whereas fiber glass is there's almost no loss to the glass. There's just whatever refraction and reflection you have, and the copper is limited to pretty much 5 meters at 25 or 100G and a little bit longer at 10G.
Then why would anyone choose copper?
Well, copper has quite a few benefits. One of which is the much lower price tag. Um, Another benefit would be that there's less power draw from the cable itself, whereas when you have either a transceiver or an AOC assembly, you have lasers involved, and those lasers take quite a bit of power to operate.
One thing I also would want to add in there is that at some point, even if you could send a signal through a, let's say, 15-meter copper cable, that copper will actually be more expensive than a fiber cable.
Ryan, what's typically the longest length that you see within a rack that's required for cabling?
Within a cabinet, it's usually about 3 meters. Cabinets range in size from 42U to 45U. Our sweet spot is the 2.5 meter cable, and that's what we sell the most.
So is half meters? I heard you say 2.5 meters. That seems like an odd length. Why are half meters important?
So, because the cables are connecting networking equipment inside of a cabinet, typically a switch to a server, the cables, the half meter lengths help the cables stay out of the way for airflow. It's better cable routing, so that way there's, like I said, better airflow, less heat, and it also has better aesthetics. The system looks better with half meter cables.
So I'm just trying to put all this together. Would you say that when you're choosing the right medium and the right type, because there's 3 types of high-speed interconnects, right? There's transceiver assemblies, there's the fiber, which we call AOCs or active optical cables, and then there are DACs, direct attached copper cables. And what do you usually start with, Ryan, when you're working with a customer? What is your go-to out of those?
Well, it's important to find out what their max length is going to be. So, at the beginning, if they say that they're going to have lengths beyond 5 meters, I usually suggest active optical cables or transceivers with jumper cables. But if it's lengths below 5 meters, I start with our copper cables. And the reason why is because there's better performance, and also they have a much lower price tag. So, I'm trying to make sure the customer knows their options, and it starts with understanding what their max length is.
Okay, so as a quick guide or just a little reference, if the lengths are shorter, I guess you would want to use copper because there's less heat involved. And if it's a little bit longer, maybe you're going from rack to rack within the row or from row to row, you want to use AOCs. And how long, Rob, how long can an AOC go? What's a typical length for a multimode fiber-based AOC?
We usually see 100 meters being about the max end of AOCs. Transceivers, they can go a lot longer than that, but AOCs 100 meters.
100 meters. Okay.
Yeah. From an application standpoint, I usually see 30 meters as the drop off for AOC usage. Beyond 30 meters, there's usually 1Z or 2Z connections, but 30 meters and below for AOCs is usually where the volume is at.
For those of you who are still with us, we'd like to add a bonus section, and this is the lightning round. So I will be firing off questions to the other three team members. And the first one I have for Ryan. Ryan, how far away are we from 200, 400, and 800 gig high-speed interconnects being required by the market?
Today, I see a few hyperscalers using 400 gig. Beyond that, I'm guessing it's probably going to be 3 to 5 years out. There's still a lot of customers that are transitioning into 10 gig. And then also other customers that are transitioning, today into 25 and 100 gig systems. And the reason why is because they're taking advantage of the hyperscalers and the price points that they were able to, bring the equipment down to because the volume that they've have purchased in the past. Right now, 400 gig is really new. There's not a lot of adoption beyond hyperscale. I don't believe there's a lot of volume beyond switch to switch, core switch to switch applications. And so I don't see it becoming mainstream in the enterprise for at least 3 to 5 years. 800 gig is going to be the driver for 400 gig. So 400 gig won't be popular, in my opinion, until after 800 gig becomes the new hyperscale standard.
Gotcha. Okay. Ready? This is like a PSA sort of question to help others. How many times do you have to change autocorrect from making HSI into HIS?
Well, that's a funny question, John. Actually, I gave up and I just spelled out high-speed interconnects.
Fantastic. Okay, David, we've kind of gone over this before, but in a nutshell, for people who have no idea what signal integrity on a third grade level, how would you explain it?
Well, it's making sure that the signal that goes in is the same signal that goes out.
That's a really good nutshell. What
Also
kind of
help
nut?
him in a nutshell.
Awesome Austin Power reference. Okay, I have one other question for you, and this is whatever team member came up with this question really knows David. How difficult is it living in a state that has no professional sports teams?
Well, the reason why this is funny is because I don't watch any type of sports, so for me,
Shuffleboard.
easy peasy.
Okay, you got no problem being in the great state of Connecticut.
Hey, we got the yard goats.
Okay, Rob, your dad was an engineer for the Siemon company. Who was better, him or you?
Oh gosh. Well, he did have some years of experience before coming to the Siemon company. I started here, and he's got, let's see, over 45 patents on me. So I definitely say him.
That was actually a throwaway question. The real question that everybody wants to know about is who's the better singer?
Well, again, it goes down to the experience thing. He was in a rock band, but I would think we're the best when we're harmonizing together.
Ah, nice answer. Kind of like our team. I think the four of us are best when we harmonize together.
Aww.
Okay. Well, that's all for today's episode of Network Connections presented by the Siemon Company. Thank you for listening. Thank you, Ryan, Rob, David. Make sure everyone listening subscribes to the Siemon Company YouTube channel so you never miss another episode. Future episodes will continue to feature subject matter experts that will deliver valuable insight into the ICT industry. From all of us here at the Siemon Company, we hope you and your family stay safe and healthy during these times, and we will see you next time. Thank you.